Hello everyone, and welcome to this lecture on binary and decimal numbers. Today we're going to explore what binary numbers are, why they're important, especially in computing, and how to convert between decimal and binary systems. We'll break it down step by step with clear examples. Let's dive in. First, let's start with the basics. You're probably familiar with the decimal number system, also known as base 10. In decimal, we use 10 digits, 0 through 9. Each position in a number represents a power of 10. For example, the number 123 in decimal means 1 times 10 squared, which is 100, plus 2 times 10 to the first, which is 20, plus 3 times 10 to the 0, which is 3. So 1x 100 plus 2x 10 plus 3x 1 equals 123. Now, binary is the base 2 number system. It only uses 2 digits, 0 and 1. Each position represents a power of 2, starting from the rightmost digit, which is 2 to the power of 0. Binary is like the language of computers, simple but powerful. Why do we need binary numbers? Well, computers and digital devices are built on electronic circuits that can only be in one of two states, on or off, like a light switch. We represent on as 1 and off as 0. This makes binary perfect for computers because it matches how hardware works. Transistors can switch between these two states billions of times per second. If we tried to use decimal directly, we'd need circuits for 10 states, which is way more complex and inefficient. Binary allows us to represent any number, text, image, or even video using just zeros and ones. Okay, now let's learn how to convert from decimal to binary. The method is straightforward. We repeatedly divide the decimal number by 2 and keep track of the remainders. The remainders, read from bottom to top, give us the binary equivalent. Take the decimal number 13 as an example. Start by dividing 13 by 2. 13 divided by 2 is 6 with a remainder of 1. Next, 6 divided by 2 is 3 with a remainder of 0. Then, 3 divided by 2 is 1 with a remainder of 1. Finally, 1 divided by 2 is 0 with a remainder of 1. Now, read the remainders from bottom to top. 1, 1, 0, 1. So, 13 in decimal is 1, 111, and over 1 in binary. Another example, let's convert 25 to binary. 25 divided by 2 is 12, remainder 1. 12 over 2 equals 6, remainder 0. 6 over 2 equals 3, remainder 0. 3 over 2 equals 1, remainder 1. 1 over 2 equals 0, remainder 1. Reading bottom to top, 1, 1, 0, 0, 1. So 25 is 101 in binary. Great, now for the reverse, converting binary to decimal. This is even easier. You just multiply each binary digit by 2, raised to the power of its position, starting from 0 on the right, and add them up. For example, take the binary number 1010 from right to left. The rightmost 0 is 0 times 2 to the power of 0 equals 0. Next one is 1 times 2 to the power of 1 equals 2. Then 0 times 2 to the power of 2 equals 0. Leftmost one is 1 times 2 to the power of 3 equals 8. Add them. 8 plus 0 plus 2 plus 0 equals 10. So 1010 in binary is 10 in decimal. One more. Binary 11100. 0 times 2 to the power of 0 equals 0. 0 times 2 to the power of 1 equals 0. 1 times 2 to the power of 2 equals 4. 1 times 2 to the power of 3 equals 8. 1 times 2 to the power of 4 equals 16. Total, 16 plus 8 plus 4 equals 28. Yes, remember, these conversions are fundamental in programming and computer science. Practice a few more on your own, like converting 42 to binary or 1001 binary to decimal, and you'll get the hang of it quickly. That's it for today's lecture. If you have questions, drop them in the comments. Thanks for watching.